Elon Musk just quietly killed SpaceX's most successful rocket. If you thought Flight 11 was a peak of human engineering, I have some terrifying news for your rocket-loving brain. SpaceX didn't just upgrade the most successful rocket in human history. They completely destroyed the blueprints, and the absolute monster they are building to replace it shouldn't even be physically possible. Welcome to the era of Starship version 3, before Flight 12 clears the tower this April. You need to understand that this isn't just another incremental upgrade. It's a complete hardware reform. We're moving from the beta version of space travel to production build, while the rest of the industry is still trying to figure out how to build a reusable rocket. Elon is out here stretching the fabric of cosmos. In this video, we're breaking down why Flight 12 is a success or total destruction moment for the Artemis program, why the Raptor 3 engine looks like it was designed by an AI with a minimalism fetish, and why SpaceX might be about to attempt the most insane maneuver in the history of physics. Let's look at the science of this insane launch. Raptor 3, the engine that shouldn't work. Let's talk about the heart of the beast. Raptor 3. If Raptor 1 was a college project and Raptor 2 was a professional engine, Raptor 3 is, well, it's basically black magic. SpaceX has achieved what engineers call the holy grail of no parts. They've integrated the cooling channels and the sensors directly into the 3D printed manifolds. Look at the Raptor 2, it looks like a plumbing nightmare in a Victorian basement. Now look at Raptor 3. It's sleek, it's terrifying. It produces 280 tons of thrust at sea level. That's a 15% jump in power, while reducing the mass. In the world of rocket science, that's like making a car faster by removing the engine and replacing it with a localized black hole. Why does this matter for Flight 12? Because version 3 starships are taller. They're heavier. They need that extra push to get Ship 39 into a true orbital trajectory. If a single Raptor 3 underperforms, the entire V3 architecture is put into question. We aren't just testing a flight. We're testing the math of the next decade. The stretch and the three-fin gamble. Size matters, especially when you're trying to colonize Mars. Ship 39 is nearly 10 meters taller than its predecessors. This means more room for propellant, more room for Starlinks, and more room for the existential dread of being on a 500-foot stainless steel skyscraper. But look at the fins. SpaceX is moving to a three-fin configuration on the ship. What is the reason, you ask? Because weight is the enemy of progress. By removing a fin and redesigning the aero surfaces, they've shaved off tons of dry mass. But here's the mind-bending part. Flight 12 has to prove that 3 fins can provide the same control authority as 4 fins during that belly flop maneuver. It's like trying to parallel park a bus on a skating rink using only your side mirrors. If the center of pressure is off by even a fraction of percent during atmospheric reentry, Ship 39 becomes the world's most expensive shooting star. SpaceX is betting their entire aerodynamic model on this flight. Infrastructure or Armageddon, the second tower. Now, let's talk about the chopsticks. With the completion of the second launch tower at Starbase, the double catch is no longer a fever dream. The rumor mill is buzzing that Flight 12 might be the first time they attempt to catch both the Super Heavy booster and the Starship. Catching the booster is standard now, which is a wild sentence to say out loud, but catching the ship, that's different. The ship is coming in hotter, faster, and with a different mass profile. If they miss the catch on the new tower, they don't just lose the ship, they potentially lose the infrastructure for the next 6 months of launches. It's a high-stakes game of don't drop the 5,000-ton rocket. If they pull it off, the era of rapid reusability isn't coming later, it's already here. The secret payload and the Artemis clock. Finally, why are we really doing this? The FCC filings for Flight 12 show mass simulators and Starlink intersatellite link tests. For the first time, Flight 12 is acting like a real cargo ship. NASA is watching this flight more closely than any other. Because if V3 works, the Artemis 3 moon landing stays on schedule for 2027. If V3 fails to reach its orbital goals, we're looking at delays that could push us back to the 2030s. We are living through the most critical transition in the history of the space age. We're moving from can we do this to how fast can we do this And Flight 12 is the answer to that question. It's a 100-meter tall experiment in whether or not humanity is ready to become multiplanetary. Or, at the very least, whether or not we can build a really big crane that catches falling skyscrapers. The simulation is lagging. So, if you're watching the live stream this April, don't just look for the explosion or the landing. Look for the Raptor 3 green flames. Look for the 3-fin stability. Look for the second tower. Because what you're seeing isn't just a flight. It's the source code of the future being written in liquid oxygen and stainless steel. What do you think? Is a double catch a guaranteed success? Or is SpaceX being too aggressive with the V3 rollout? Drop your predictions in the comments. I'll be there arguing with the laws of physics. I'll be covering the whole Starship Flight 12 and break down the day it flies. So make sure you're subscribed and hit the bell so you don't miss it.